Hi, today we're going to do exercise 4 from May-June 2020, paper 41 from the A-Level Maths 9709 code from Cambridge. It is a very interesting exercise because it is a rod with a ring and a force that's pulling a rope that's pulling the ring, and it's just before it says it's at rest. We have several exercises like this in past papers. There's another one where it's vertical, and it's basically more or less the same. So let's start with this one. Okay, so as in all of these exercises, what we have to do, the first thing we have to do is draw our forces, okay? So if our ring is here, and this is our tension, and this is 30 degrees, I'm going to draw the forces that we have there. So remember and look at that the rod is rough. Okay, so the rod is rough. We have a force of friction. Force of friction goes against movement. It's not moving now. It's just about to move. We have to consider it's just about to move. So, if we're pulling to the right, I have to suppose that the force of friction is going to go to the left. So that's the force of friction. We also have the weight of the ring, because it has weight, and a reaction force here. Okay? So those are all our forces. Now, second step, every time you have this kind of exercises, the next thing you have to do is draw some axes. So we're going to consider the x-axis and the y-axis. And the next thing is any forces that are not on the axis, you have to find their components. So we have really a t in the x-axis and a t in the y-axis, where tx is t cosine of 30 because it's the 30. Tx is beside the angle, is the contiguous side, and ty is opposite, so it's with a sine. Okay, that's the first thing we have to do also once we found the forces. So now we have all forces on the axes, and we have to basically use our Newton's second law of motion, which it says, but on each axis. So on the x-axis and the y-axis. On the x-axis, we know that the law of motion says that the sum of the resultant of all our forces in the x-axis equals mass times acceleration, but that's zero because it's not moving. Okay, so what forces are on the x-axis? So basically, we're going to consider right is the positive direction. So we have tx minus fr equals 0. So basically, t cosine of 30, which was tx, equals our resistance force. Okay. Whenever we have resistance force, we usually have to also do the second law of motion in the y-axis. Why? Because we have to remember that the force of friction is our coefficient of friction times the normal in this case. So yeah, times the normal, which is, we've called it r. Okay. So our second law of motion in the y-axis is also 0 because there's no movement, and in the y-axis we have r minus w and minus ty equals 0. So r equals w plus ty. Okay, which is logical because that, if not, the rod would break. So we are given a coefficient of friction which is 0.8. So we know that we basically know if we r is equal to that, and that's w plus t sine of 30. Okay. If we use that, fr is going to be 0.8 times w plus t sine of 30 And if we use that on the equation of the x-axis, we have that, I'm going to continue here. So we have that t cosine of 30 equals 0.8 w plus 0.8 sine of 30 times t. Okay? So we're going to move all the t's to that side. So t cosine of 30 minus 0.8 sine of 30 equals 0.8 times mass, which was 0.1, times gravity, which is 10. Okay, so that's 1. So that's 0.8. Okay, so t equals 0.8 divided by all that division, which is cosine 30, blah, 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 which is, okay, so that's 0.466. So 0.8 divided 0.466. So that's t is 1.7167, which is 1.72 with 3 significant figures, newtons. So that's the tension that would just keep it at rest and be about to move. Okay? So, first question, let's go to the next one. So the next question says, find the acceleration when t equals 3. So we had in the x-axis that the t cosine of 30 minus our friction was, in this case, as it's moving, mass times acceleration. Okay. I'm going to put all the equations that I have. So we had in the y-axis, we had that as it's not moving in the y-axis, it's still 0. So we still have that the r equals w plus t sine of 30. And the fr is still 0.8 times w plus t sine of 30. So we have here that the acceleration is going to be t cosine of 30 minus 0.8 times w plus t sine of 30 divided by our mass, which was 0.1. Okay, so now that's 3 times cosine of 30, so that's 5.98 meters per second square if we use 3 significant figures.